Hi, welcome back to my YouTube channel. In this video we're going to see how we should solve this integral from 0 to pi over 2. Actually, it should have been pi over 2 of ln of 1 plus sine x cosine x tan x over 1 minus sine x cosine x tan x. So here first, what I'm going to do, I'm going to see how I'm going to just expand this and write it in better form using trig identities: sine x, cosine x, sine x, cosine to the power of negative 1x divided by 1 minus sine x, cosine x, sine x, cosine to the power of negative 1 of x dx, which is sine x over cosine x, which is tan x. So I'm going to cancel these two out, these two cosine x, and this cosine x with this cosine x is also going to be canceling out. And I can write my the integral, as the integral of 0 to pi over 2 of ln of 1 plus sine squared x divided by 1 minus sine squared x dx. And if you remember, this identity 1 minus sine squared x is actually cosine squared x, because cosine squared x plus sine squared x equals always 1. And I can therefore write this integral as from 0 to pi over 2 of ln of 1 plus sine squared x over cosine squared x dx. Now the integral is going to be the integral from 0 to pi over 2 ln of 1 over cosine squared x plus sine squared x over cosine squared x with respect to x. Now this is going to be ln of 1 over cosine squared x is secant squared x plus tan squared x dx. So now what I can do here is I can expand secant squared x as the identity of 1 plus tan squared x, and my whole integral here is going to be from 0 to pi over 2 of ln of 1 plus 2 tan squared x with respect to x. So here I'm going to define y to be tan x, and x is going to be arctan of y. Thus dx is going to be equal to 1 over 1 plus y squared dy. So here is my dx here, and my y is tan x. Thus my integral is going to be this integral from 0 to arctan of tan of pi over 2 is infinity, so it's in 0 to infinity. It's a limit concept. Ln of 1 plus 2y squared multiplied by 1 over y squared plus 1 dy. So let me write it more clear here. The integral from 0 to infinity of ln of 1 plus 2y squared over y squared plus 1 dy. Now what I can do here, I can define I as a function of a, and I say that it is ln of 1 plus ay squared over y squared plus 1 dy. And if I find I of 2, my integral is going to be from 0 to pi over 2 of ln of 1 plus 2y squared over y squared plus 1. Thus I have to find I of 2 according to the finance technique. So first I'm going to take the derivative of this integral with respect to a. It's going to be partial a of ln of 1 plus ay squared over y squared plus 1 dy. Now I prime of a is going to be from 0 to pi over 2 of 1 over 1 plus ay squared according to the chain rule. It's multiplied by y squared times 1 over y squared plus 1 dy. So here I prime of a is going to be the integral from 0 to pi over 2, 0 to infinity, just forget to change my balance, 0 to infinity of y squared over 1 plus y squared plus 1 dy. I prime of a is going to be, I can do this. I can factorize 1 over 1 minus a, the integral from 0 to infinity of y squared over 1 plus y squared, 1 plus a y squared dy. So here I can do fraction decomposition. You can do it on your own, but I'm not going to do it here because it's going to be a long video. The integral from 0 to infinity of 1 over 1 plus y squared of 1 over 1, no, sorry, my mistake here. 1 over 1 plus ay squared minus 1 over 1 plus y squared. Now we're talking dy. So my I prime of a is going to be 1 over root a arc tan of root a y minus arc tan of y from 0 to infinity. Arc tan of infinity is pi over 2, thus I'm going to get 1 over 1 minus a times 1 over root a pi over 2 minus pi over 2. So here I can write I prime of a as pi over 2 times 1 minus a multiplied by 1 minus root a over root a multiplied by root a plus 1 over root a plus 1. And I can ultimately write I prime of a as the form of pi over 1 plus root a multiplied by 1 over 2 root a. And if I integrate both sides now with respect to a, I am going to get I of a to be equal to pi ln of 1 plus root a plus c, some constant of integration. And in order to find c, the constant of integration, I need to equate it to the integral from 0 to infinity of ln of 1 plus ay squared over 1 plus y squared dy equals pi ln 1 plus root a plus c. And if my a goes down to 0, I'm going to take the limit as a approaches 0 of both sides. Thus, this integral is going to go down to 0, and c plus, it's going to be c plus pi ln 1. It's going to be 0. C plus ln 1 is 0, thus c plus 0 is 0. This c is equal to 0, therefore. Now, I can write my I of a as pi ln of 1 plus root a. Sorry. And I was looking for I of 2. Therefore, if I plug in 2 here, I'm going to get pi ln of 1 plus root 2. And this is the exact value of our integral. And therefore, I can write the integral of from 0 to pi over 2 of ln of 1 plus sine x cosine x tan x over 1 minus sine x cosine x tan x dx as pi ln 1 plus root 2, which is derived with the Feynman's trick, the modern Feynman's trick of integration. Thank you for watching my video. I hope you've understood my solution in the video. If not, please let me know in the comments, and I will see you next video.